Okay, another radical equation, another equation with the square root symbol on it. What do we do? Well, typically with equations, we'll try to use inverse operations and work backwards. And we might want to try to get that x by itself, but I got to get rid of the radical. I got to get rid of that 5. I got to get rid of those x's, but I can't do any of that yet until I get rid of this 6. That thing is not being protected by the radical, so to speak. So I can get rid of that on its own first. The rest are. So we're going to isolate that radical. X times x minus 5 equals 6. Now that we get here, we now can get rid of that radical because everything is underneath it. And the opposite of square rooting something is to square it. So if I take this whole thing and square it, that'll get rid of it. And I'm allowed to do that with equations as long as we do the same to the other side. That cancels the radical on one side. Everything else remains. And then this just gives us 36. We can continue to try to use inverse operations here, but I'm actually going to distribute. And when I distribute, I'm going to see that I've got a quadratic equation. A quadratic because our exponent is 2. And so now what do I do? Well, how do I solve exponential equations or quadratic equations? I set them equal to 0. No, I don't just move the 36 over. I subtract it from both sides. And then I try to factor. Okay, what are our factors of 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Will any of those give us 5, 4 and 9 if we subtract them? As long as that 9 is the negative, that will give us a -5 on the inside. So we got a negative and a positive there. Those are not our solutions. Those are our factors. We set each one of those equal to 0. We get 9 for one case. Set this equal to 0. Oh, you know what I'm saying. X equals -4 over here. We got 2 solutions. Now, on your problem, you added those together. Beautiful, whatever, moved on, but you did not check. We have to remember that these types of equations could have extraneous solutions. They could. If we check, we will know for sure. And so with log, we have to check. With radicals, we have to check because each one of those kind of plays by its own different set of rules. So let's go ahead and let's do that check for each one of those. So for the first one, I'm going to put my square roots. I'm going to do 9 first, and I'm going to do 9 minus 5 on the inside, and then a -6 on the outside. I want to see if that gives me 0. That's going to give me 9 times the quantity was 9 minus 5. That's 4. Let's square root that. That gives me 36. Subtract 6. 6 minus 6 is 0. Boom, that one actually works. I'm going to put a check mark next to that one. The other one that I'm going to now check is -4. So let's go put -4 in for X. I'm doing my check over here, forgive me. And -4 in for X. And then I'm going to subtract 6, see if I get 0. Well, I get -4. I get -9. That gives me 36. Again, that's just like the other problem. I get 6 minus 6, which is 0, which is what I need it to be. So that one also works. This will not always be the case. You need to check. It's not like they're always going to both be solutions or neither or whatever. You have to do that check for extraneous. In this case, they both worked because they both checked out. So problems 12 and 17, both radicals, both need to be checked for extraneous solutions. Make sure you're isolating those radicals before you get rid of that square root. Good work.